let's take a look at one more example. In this example, we're going to sketch the region and then compute the value of the integral. So, in this particular one, the region is the region bounded by y equals 2x squared and y equals 1 plus x squared. So let's draw what we're going to be looking at. So y equals 2x squared, that's a parabola, passes through the origin. So there's our parabola. And then y equals 1 plus x squared, that's also a parabola, would be a parabola shifted up 1 unit. And if I actually graph that, and you could do this on your calculator and confirm that this is what it looks like, it would be a little bit more open than the other one. And so what I notice is the region I'm looking for is the region that falls in between the two. So this one's y equals 2x squared, this one's y equals 1 plus x squared. So there's my region. Now I want to compute the value of the integral. Now to compute the value of the integral, I have to actually set up the integration. So I'm going to integrate, and let's see, the function was x plus 2y. Now, I need to figure out which is going to work better for me, dx, or dx dy, or dy dx. Now one of the things I notice is if I actually end up down here, I end up having the left and the right being the same function. But up here, the left and the right become different functions, and in fact I have this kind of split. So I'm going to have to be a little bit careful about the way that I do this. And so what I'm going to choose to do is I'm going to choose to do my outer limit as the x's, because that's the one that seems to be giving me some trouble. So I'm going to go dy dx as my setup here. I'd encourage you to try it the other way, see if you can get the same answer. But quite frankly, this is going to be the one that's going to be better because my inner limits will be the y's, and notice for the entire time the same thing happens. The bottom one is y equals 2x squared, the upper function is y equals 1 plus x squared. So it's going to make more sense to go dy dx. So again, in order to find the limits, I'm going to have to find these x values. Well, those x values are where the two functions are equal to each other. So let's do a little algebra. 2x squared equals 1 plus x squared. So x squared equals 1. So it looks like x is plus or minus 1. So my outer limits are x, so it's going to be negative 1 to 1. My inner limits are the functions. And remember, we have to give them in terms of x, which that works out real nicely for us. Bottom function is 2x squared. Top function is 1 plus x squared. And now I'm all set. Outer limits were x limits. Inner limits are y limits. Y limits can only involve functions that are in terms of x. So now let's integrate. Outer limits we'll leave alone. We're going to integrate with respect to y. So antiderivative of x is xy. Antiderivative of 2y is y squared. And then from 2x squared up to 1 plus x squared. So let's substitute in. So that's going to give us negative 1 to 1. X, upper limit is 1 plus x squared, plus, substitute in for y squared, that's 1 plus x squared squared, and then we'll subtract, put in the lower limit, that's x times 2x squared, plus 2x squared squared, and then we'll have dx. So if I neaten this up a little bit, negative 1 to 1, let's see, that's going to give us x plus x cubed plus, now I need to square this out, that's 1 plus, and when I square that, that's going to give me 2x squared plus x to the 4th minus, when I multiply those, that's going to give me 2x cubed minus distributes, 2x squared all squared is 4x to the 4th. So So again, be careful. This is the one that you might need to do out. I did the math out in my head, right? 1 plus x squared squared. And that's the part that gave me this piece. Let me just combine some like terms before I go forward. Looks like I only have one x. I have x cubed and a minus 2x cubed, so that's minus x cubed. I only have one number, and then I just have 2x squared, and then these x to the fourths I can combine. That's going to give me minus 3x to the fourth dx. Now, let's integrate. Antiderivative of x is x squared over 2. Antiderivative of x cubed is x to the fourth over 4. Antiderivative of 1 is x. Antiderivative of 2x squared will be 2x to the third over 3. And antiderivative of 3x to the fourth will be 3x to the fifth over 5. All of that from negative 1 to 1. So let's see, if I plug in 1, it's a half minus a quarter plus 1 plus 2/3 minus 3/5. Then plug in negative 1. Remember, the even ones will square back to positives, so that's going to give me a half and a quarter, minus a quarter. But all of these will actually change signs. So I'm going to have minus 1 minus 2/3 plus 3/5. So I'm going to get some cancellations here when I go to do the math. A 1/2 and a minus 1/2, and a minus 1/4 and a positive 1/4. But then these are going to change signs, so I'm going to end up getting 2 plus 4/3 minus 6/5. And I would pull out my handy-dandy calculator and do some math. I'm too lazy to pull mine out. Common denominator is 15. So that's going to give me 30 plus 3 goes into 15. 5 times 4 is 20. 5 goes into 15. 3 times 6 is 18. So it looks like it's going to give me 32 over 15. So some of that I probably went through kind of quickly. You might want to go back and actually check out the math and do it out yourself. Double check. So Mrs. Smith will be telling you what your homework is, and then we'll have you taking your quiz after we give you a short break.